Okay, we're on Geometry 4.8, Isosceles and Equilateral Triangles. So let's just start off by remembering or recapping what an isosceles triangle is. Isosceles triangle is a triangle with at least two congruent sides. Man, my pen's not working. Sorry. Two congruent sides. So I say at least because it could have more than two, because you recall our little Venn diagram of isosceles triangles. We could also have kind of a subset in here of equilateral triangles because look at that, it kind of looks like a jack-o'-lantern. Equilateral triangles have two sides that are the same, but they also happen to have a third side that's congruent, so all three sides are the same. Okay, so isosceles have at least two sides. So let's just talk about the parts of an isosceles triangle. We're going to say that this triangle right here is triangle A, B, C. So we're given triangle ABC, and triangle ABC is isosceles with vertex. Man, my pen just won't write. With vertex angle B. Okay, so here's some things you need to know. So this is the vertex right here, angle B. And on an isosceles triangle, when we're given the vertex, the two sides that form that vertex are what we call the legs. So this would be a leg right here, and this would be a leg. And those are also the two congruent sides by definition. So, yeah, the two legs are always form the vertex. And then the side that's opposite the vertex, which is down here, is going to be called the base. So the base is always opposite the vertex. Now, something that you may be starting to clue in on is the angles that are on these triangles, isosceles triangles. If these two legs are the same, you may have begun to recognize that these angles are also going to be congruent. So the angles that are opposite the legs are going to be congruent. So we have a little theorem that states that, and it's the isosceles triangle theorem. And it says if two sides in one triangle are congruent, then the angles opposite the sides are also congruent. Okay, isosceles triangle theorem. If two sides of one triangle are congruent, then the angles opposite those sides are congruent. So, yeah, sorry about the bad handwriting. I don't know what's up with my little pen tonight. It's not working very well. Okay, so I could go through the proof on how we figured that out, but I think I'm going to skip it for now and just move through the notes. Okay, now I also want to mention that this theorem, isosceles triangle theorem, the converse is true. So, if you think about this being a conditional statement, if two sides of one triangle are congruent, being P, and then the angles of the opposite sides are also congruent, that's Q, then what's the converse of that? Remember, converse is Q, then P. So we can say it like this. Converse of isosceles triangle theorem. If two angles in one triangle are congruent, then the sides opposite those angles are also congruent. Okay, so let's look at some examples of this. We'll start with example 1 here. It says, use the diagram to find x if triangle ABC is isosceles with vertex A and the measurement of angle A is 130 degrees. Okay, so let's fill in what we know. Here is vertex A, and so we know that since this is an isosceles triangle, we know that AB is congruent with AC, and we're told that the measure of angle A is 130 degrees. Okay, so let's think about what else we know here, just based on our theorem. Since this angle C is x degrees, what can we say about angle B? We can say that angle B is x degrees. And what's our justification for that? Let's justify that. And that would be if two sides of one triangle are congruent, then the opposite angles are also congruent. Okay, so now let's see what we could do. How could we set this up as an equation to solve for x? Well, let's think about this. What do we know about the three angles, the interior angles of a triangle? The three angles add up to 180. So we could say that x plus 130 equals 180 degrees. So we have 2x, and I'm going to subtract 130. I'm going to do this all in one step. 2x is equal to 50, and so we divide by 2, and x equals 25. And so that's our answer because it says find x, so x is 25 degrees. Bada bing, bada boom. Okay, now I'm pretty sure that you could be able to solve number 2 yourself, so why don't you try that? Give it a try and make sure you justify your answer. Justify. Okay, well, I hope you hit pause and tried that yourself. So what we need to do here is take 7x plus 35 and set it equal to x plus 65. Now, why would we do that? Because if two sides in one triangle are congruent, then opposite angles are also congruent. So we see these two congruent sides, so their opposite angles are going to be congruent. So we end up with 6x equals 30, and divide by 6, and x equals 5. And there we go. Let's move on. Okay, so on example 3, which I feel pretty sure you could do without my help, we need to find the value of AC, the measure of AC, in isosceles triangle ABC with vertex B. So if B is the vertex, then we know by definition that 3x minus 18 is congruent with x plus 10. And how do we justify that? That is definition of an isosceles triangle, because the two legs of the isosceles triangle are always part of the vertex. Okay, that's what forms the vertex. So we can say, since those two sides are congruent, 3x minus 18 is equal to x plus 10. So we're going to subtract x, and we get 2x minus 18 equals 10. Add 18. 2x equals 28. And divide by 2, and x equals 14. Okay, but that doesn't answer the question yet, because we need to find AC, and AC is right here. So we're going to substitute 14 for x, and so we have 14 minus 3, and so AC equals 11. Okay, so on example 4, this next proof is a little more dicey than what we did on the front page. So let's see if we can't map out a plan for doing a proof. So we're given that triangle AJS is congruent with UJT, and then we need to prove that triangle AST is congruent with UTS. So first of all, I'm going to pull out those two triangles that we're trying to prove. And so we have ATS, and then we have UTS, AST and UTS. Okay, and so let's think about things that we know for sure. Let's see here. Okay, sorry, I got a little bit interrupted there. So let's see here. Let's start with the fact that we were given AJS is congruent with UJT. So that's this triangle and this one right here. So if those two are congruent, let's think about what we know. We know that this angle A, is congruent with angle U. Okay, and let's see here. We know that line segment JS is congruent with line segment JT. Oh, well, now that helps us, because if we have two sides in one triangle that are congruent, what do we know about their opposite angles? Then we know that this angle right here is going to be congruent with this one right here. So if we were to mark those things on our little orange ones down here, we have angle A and angle U, and then we're going to end up with this side, not side, this angle right here being congruent with this angle right here. And then what else do we know? Well, when we look at this picture up at the top, we can see that this side right here is a side on both the triangles, so we can call that congruent on the reflexive property. So we're going to end up with what? We're going to have an angle, angle, side, angle, angle, side. So that's our plan for doing this proof, so let's go ahead and write it out. So we have our statement and our reasons. So let's start with, how about we start with this green side right here. We can say that line segment ST is congruent with ST, and that would be the reflexive property of congruence. And then we can say triangle AJS is congruent with triangle UJT, and that was given. This is number 1. This is number 2. Okay, number 3. Let's see here. Now, what do we know about angle SAT? Angle SAT is congruent with angle TUS. SAT is congruent with TUS, so that's these angles right here, which are these right here. So we know that. How do we know that? Because let's go way back to the beginning. We know that these two triangles have been given as they were given to us as being congruent. So we can say CPCTC. Congruent, corresponding parts of congruent triangles are congruent. Okay, let's go to number 4. And we can say that JS and JT I actually put my line on the wrong place. JS and JT are congruent. And how do we know that? Same reason. Because we're still basing that off of these small triangles right here. So CPCTC. Okay, and so as a result of that, we can say, number 5, that angle UST is congruent to angle ATS. So that's these angles, which we did up here. And that would be, our justification for that is back to our theorem on the front page. If two sides of one triangle are congruent, then opposite angles are also congruent. Okay, and then finally we can do our proof. 6, triangle AST is congruent with triangle UTS. And what are we using for that? AAS. So let's make sure we have our statements in there. Here is a side right here. And here's a congruency statement for those angles, and here's another statement for those angles. So we have our angle side in statements 3, 5, and 1. Okay, let's do the last two. We're almost done. Okay, now before we do these last two examples, you need to know one quick thing. You already know this, but we need to just make sure we have our justification in order. When we talk about equilateral triangles, if you have a triangle that has all three sides congruent, then your angles are all going to be congruent as well. And we say that if a triangle is equilateral, then it is equiangular. Equiangular. So, and sort of in shortened form, equiangular, just like equilateral means all three sides are congruent, equiangular means all angles are congruent. Okay, so let's do number 5. It says find the value of x. Okay, well, it's showing us that this expression, 3x minus 18, was for this angle. And what do we notice about this triangle? All three sides are equal. So that means all three angles are equal. And so when we're talking about triangles that add up to 180, that means all three angles equal what? They each equal 60 degrees. So if we want to find x, we can just take 3x minus 18 and set it equal to 60. So we add 18 and you get 3x equals 78. Divide by 3 and x equals 26. Okay, now let's go to example number 6. Okay, it says find xy. So you'll note there's no line above it. When it's just xy, we're talking about the measurement. So we need to find the value of this distance right here. So it says, note, angle x is congruent to angle y, which is congruent to angle z. And if that's the case, if a triangle is equiangular, this works both ways. If it's equilateral, it's equiangular. If it's equiangular, it's also equilateral. So if this is equiangular, then we know that these three sides are congruent. So that makes it easy to solve for x. We're just going to take these two and set them equal to each other. 7x minus 24 is equal to 3x plus 16. And so let's subtract 3x. Add 24. So 4x equals 40. Divide by 4. X equals 10. But don't make sure you're not answering that as your answer, because it doesn't ask us to find x in this problem. It says to find the value of xy. So we're going to take this 7 and put in 10 minus 24. So that's 70 minus 24. So xy equals 46. Now, theoretically, if this side right here has a measurement of 46, then this side should too. So let's just try it just to make sure we did our math correctly. 3 times 10 is 30, plus 16 is 46. Bada bing, bada boom. Okay, so there you go. That's your lesson. See you in class.